Hi, my name is Stephanie Labou, and I am the data science librarian here at UC San Diego. To me, data science is extracting meaning out of the massive amount of data that is in everyday life. And it's also really automating that extraction, so it's not something that we can necessarily do manually. And it's also thinking critically about data. So we might have more data than ever before, but we need to know what kind of data we're working with and where it came from, because that will inform the results that we get out at the end. Being a data science librarian is pretty new. So data librarians have existed in libraries for many decades, and they were the people that really had the old, the microfiche films of census data back before, it was digital or CDs or floppy disks. And now everything is pretty digital. So data science librarian is a little bit of classic data librarian. So it's a little bit of programming, a little bit of help with statistics and visualization and computing, and all of that wrapped together, tied with a bow, is the data science librarian. And as someone fortunate to be one of the first official data science librarians, I feel very honored to help kind of define the path of what that means, especially because we have so many fantastic resources here in our major and HDSI. It means I can sort of chart my own path because there's not a huge precedent, because data science is developing so quickly. So it's really fun to be able to say, data science librarianship is 90% this and 10% whatever I want it to be, which is really fun. So for me personally, I'm really excited in this sort of meta research of data science. And so I'm working on a funded project right now looking at how data scientists take their research outputs and document them and preserve them. And so we're specifically looking at machine learning models, which are usually really, computing expensive and time intensive to create. And we would like them to be shared and reused if possible. However, there aren't really formal guidelines yet for how people should be documenting all the different parts of their machine learning model. You've got your training data, your test data. There are all these other moving parts that are often not documented. And without that information, it's really hard for another researcher to reuse that model or run that model on their own data. And so we're looking at how researchers share those, what information they share, and then how do we even preserve this big research ecosystem that has all these different subcomponents. And that is really where data curation comes into play. And so our research data curation group is really interested in helping preserve the research output and share it and make it reusable and reproducible. Every time I meet with a student or a faculty member, it's a chance to have a conversation about what is good data, because that is also really subjective. And so as a librarian, I tend to focus on, is it an authoritative source? So, a government agency that has the directive to study homelessness or, mortality statistics. They are sort of the authoritative source. So that's a good way to find data that is going to be correct. Is the methodology available? Can we look at it and talk about how the data was collected? And so these are the kind of questions that I will talk to students and faculty about when they come in and say, I just need this one thing. And so we'll have a deeper conversation about what the project is, why you need that data. Maybe what they're looking for doesn't exist, but something very similar does. Another good example is data that you can and cannot use. So especially for students, they want to web scrape everything, which is a great skill to learn. However, web scraping often violates a website's terms of service. It's in, the big block of text that nobody ever reads, but it actually is a violation. You're not supposed to do that. And so having conversations about just because you can doesn't mean you should. You should still abide by the terms of service and make sure that the data you're using is legally accessed and is then nobody's private data that shouldn't be shared, and so on and so forth. One area that has come up a lot recently with our grad students and our faculty is advising on text mining. And so it's a really popular topic these days. Everyone wants to look through 30 years of journals or newspapers or things like that. And we do have databases that have that information. And so when we're talking about information access and data literacy, it's really sitting down with the researcher and having that discussion about what they're looking for. So we want the newspaper or journal article or whatever it may be to be machine readable. If it is a photograph of something, of an old newspaper, that's going to be really hard to work with. So we want to make sure that it's in the right format for them. We want to make sure that we don't have to worry about any sort of copyright issues. It's already been rights cleared for text mining. And then we want to make sure that they can actually get their 50,000 journal articles or 30 years of New York Times backlog, essentially. And so it's sometimes really hard to get batch exports from databases. And so we've worked with those vendors to really set up a way for, instead of researchers bringing the data to them, we can bring the researchers to the data. And so we have special platforms that we can give them access to. And once they're there, they have access to everything. So instead of going through and getting, 10,000 articles from here for faculty member A, 50,000 from here for faculty member B, we can set them both up with access and say, have fun, do whatever you want to do. We've made sure that you have permissions. Everything is machine readable. Have fun and let us know how it goes. So that's where we can kind of set them up for success. For gold standard of data, it really does vary. Some of the things to consider, though, are, is it current? Is the information recent if you are looking for recent information? What is the time span if you're looking for historical information? Is the agency or organization that's putting out the data reputable? So do they have a long history of good research, or did they kind of come out of the blue in their fringe organization? Also, we think about who is interested in the information, who might have agendas for the information. So is it information that is coming out of an organization that is trying to prove a particular point? So this is often if organizations have political agendas, right? Do we know the methodology well enough to be able to say, I do trust that this survey was undertaken properly, right? If the survey says, how much do you love this thing? A lot, a little, or I love it so much, right? There's no option to say, I don't love it at all, in which case your data is not really great. It's pretty skewed and you're not going to have great results. And then is it accurate to the best of our ability? So this is really where, if the methodology is available, we can look at the survey instruments, look at the methodology. And then one that I always like to think about too and have students and faculty consider is, did we get the data by legal and best means? And oftentimes this doesn't mean that someone is going and doing something shady. It means that they found some data online and ran with it. However, when I have gone and looked at it, I've said, okay, this definitely was not accessed or collected in a way that was appropriate. So it's got people's personal information. Nobody gave consent to have their information collected in this way. A lot of information that is public doesn't necessarily mean then you can go and do whatever you want with it. And Twitter data is a really good example of this. So yes, all tweets are public unless your account is private. We all agree. However, there's a difference between tweeting and if a researcher grabbed all your tweets and then was publishing them and sort of, calling you out in these published papers, you would feel kind of violated. And so we often try to think that people are behind every data point, or something real is behind every data point. And so for the Twitter example, if you want to then share out this data set you have of tweets, you need to make sure to, again, abide by the terms of service. For every single, data point or gene sequence, knowing where it came from, what it is supposed to be, if it is a combination of multiple other things, if it's a derivative of different variables. And so really having that documentation is something that we encourage. So you never know when someone's going to want to reuse your own data. And when you reuse other data, you want to have the best possible information. So it's sort of, playing nice, right? If you want to get really well documented data that is clean and ready to use, and there are no errors, and everything has been clarified in the documentation, you want to do the same thing with your own data, because it's really frustrating to find mistakes in published and shared data, but it's even more frustrating if you don't know there are mistakes and find out way after the fact. And so really exploring any data that you find before you use it. From the basics of, are there any missing values? Does this look suspicious? So let's say I have, a temperature data set and I have a value of like 19,000 degrees, and this is supposed to be temperatures in San Diego. I would be suspicious that something has gone wrong. It's been really hot this week, but it's not that hot. And so really taking a look at any sort of outliers in the data set, anything that doesn't look quite right, and diving into that. It might be a real data point or it might be a mistake. And so making sure that you explore your data to get a really good feel for it before you throw it in a model, I think is crucial. And that sometimes is a step that people skip over because they're really excited, but it is really important to really understand the data that you are putting into a model, because otherwise what comes out of it is not going to be accurate. I think it is important to remember that for a lot of data, there are real people under it. And even for data that's not necessarily, people-driven, so, climate data or oceanographic data, there is always some sort of real thing that is underlying these data points. And it's especially important for demographic data or user data or social media data. And I think that's something that can be hard to remember and people lose sight of when we're talking about really big data sets. So I think it's important to remember that each data point is actually a person. And it doesn't mean that you can't do the research, but I think it means approaching data science with a level of empathy and understanding. And so a lot of what will tell students when they're thinking about projects is, imagine if someone took your data this way. And if that would make you kind of flinch and make you feel uncomfortable, that is a hint to you. And it's also really important to think of and not be blind to data is just the way society is. So a common example is predictive policing. So every year I have students that come. It's a really common first project to make a model that will predict crime. However, this carries a lot of baggage. And so it's really easy to go out and find arrest statistics and demographic data and information about crimes. And if you're not thinking critically about the data you're working with, it is all too easy to write a few lines of code and make a model, have a result, and assume that result is somehow an inviolable truth of the universe that you have managed to find. Really, your data is a product of hundreds of years of societal pressures and influences. And so who gets arrested, for what crimes, what sentences they have, levels of recidivism, is really impacted by, social issues. And so that's an example that gets used a lot. Predictive policing as something where the model is pretty inherently biased just because of who gets arrested. But that's a pretty straightforward example. I think what's important is to take that thought process and apply it to other things. So really thinking through, if you are putting demographic data into a model, what does that data really represent? And where do you have confounding factors? I'm really excited about the focus on data in data science. I know that sounds a little strange since it's in the name, but there's been a lot of focus and excitement about methodologies for data science. So machine learning and neural networks and AI, and those are all very exciting things. But I think recently we've seen a trend that I hope continues in the future of really critically analyzing the data itself. So the data that goes into your machine learning model or your neural network, and saying, where was it collected? How was it collected? Is the data biased in any way? Is there anything in this that would then travel through my model and influence my outputs and my results in a way that is not necessarily accurate to the underlying scenario? And so I think that increasing level of data literacy and really interrogating the underlying data is an exciting avenue for data science. I don't think it takes anything away. I think it only makes the results richer. And so I think being in the mindset of we are stewards of the research that comes out of our university, and we want to make it accessible and ideally for it to have an impact. And it can't have an impact if it is poorly documented or not shared with the appropriate context, or if we are not communicating the nuances in what is coming out of our data science research. And so I think that kind of mindset of helping it along is a real opportunity and a strength of the university.